Hi, this is Hannah,
And Rajvi.
and we'll be presenting on the 3D print of the inner ear. Our client's name is Alex, and she is currently a third-term Doctor of Physical Therapy student at the University of St. Augustine for Health Sciences. She has been legally blind since birth, however, has not let her visual impairments get in the way of her education or becoming a physical therapist just like her father. She has a very supportive family who has always found ways to adapt their environment in order for her to follow her dreams. Her school has also been very supportive with providing her the assistive technology needed in order to understand the concepts and prepare for examinations. She is currently taking neuroscience and learning the vestibular system. However, has been having trouble understanding the vestibular system as it relates to balance and coordination.
Alex's main role is being a DPT student and participating in the occupation of formal education. She values having a good education and working hard no matter her circumstances. Her strengths are that she has great mental functions and excels when she has the ability to learn through tactile models. Alex's current context and environment is very supportive of her learning, as her school is able to provide her with the necessary assistive technology for learning. As Alex has expressed concern of learning the vestibular system, her current neuroscience teacher requests 3D printing of the inner ear for better understanding of the concept.
The Human Activity Assistive Technology model will be used to guide intervention as it focuses on the person and their desired activity and how assistive technology can aid in that process. Alex is a human and her activity of choice is learning in her neuroscience class. This presents with the need for assistive technology, and the 3D model of the inner ear will be created. The model of human occupation will also be used to guide intervention, as MOHO focuses on volition, habituation of their actions, and eventual performance of their desired occupation. Alex currently has great volition, as she is a highly dedicated student. Habituation will be applied with the 3D model and creating a schedule for learning and studying the model, which has the potential for optimal participation in her desired occupation of being a physical therapy student.
A 3D model will be used as Alex's AT, as studies indicate that the use of physical models over textbooks and 3D computer models benefit students with their learning both objectively and subjectively. Tactile manipulation and usage of multiple senses when learning is believed to promote a better understanding of spatial information, which results in an increase in student comprehension of the material. There has been benefits to using 3D print models in education, as they are low cost and able to be customized to the purposes of the student's education.
This is the sketch of the 3D model of the inner ear, which includes the semicircular canals and the cochlea. At initial evaluation, Alex and her professors' concerns and opinions were discussed. They wanted a 3D model of the inner ear that was durable and included engraved numbers to match a key for anatomical reference. Nylon material will be used as it is highly durable and semi-flexible. A downloadable key will be sent to Alex for easy access of text-to-speech on her computer. Key rings will be attached to the semicircular canals to demonstrate the different planes of movement.
The intervention approach of Modify will be used, as this approach attempts to find ways to change either the context, demands of the activity, or environment for optimal performance in the desired occupation. In Alex's case, the context of learning will be modified, as she will have 3D print models to use to understand the workings of the inner ear as it relates to balance and coordination. Education and training will be used as the intervention type, as students of Alex's class and professor will be educated on the importance of 3D models in education, and Alex will be trained in using the model for optimal learning.
One 60-minute session focusing on education and training of the inner ear model will be provided for Alex, her professor, and her classmates. During the session, Alex will receive training on how to use the model independently when studying. She will also receive instruction in how to direct a tutor or another classmate in assisting with the device when studying. The professor and classmates will receive education on the benefits and value of using a 3D anatomy model for persons with visual impairments. They will also receive training in the use and maintenance of the model. The professor will also be taught to focus on Alex's strengths in order to foster positive behaviors when using the model during class. Follow-up will be done in 2 weeks to see if the model had a positive impact on learning for Alex. If repairs or modifications are needed, the model can be easily fixed through 3D printing at a low cost.
According to the article about assistive technology abandonment, some risk for abandonment are not considering user opinions, ease of device procurement, and change in user priorities. With Alex, these will be taken into consideration, as the model type and development was discussed with Alex and her neuroscience professor, as they will be the ones using the models. Regarding ease of procurement, a study done in a school with students with visual impairments demonstrated a lack of assistive technology use because they had trouble obtaining AT for educational purposes. However, because Alex's school has a 3D printer, the model can be developed on campus, making AT accessible for her. As Alex and her professor use the model, changes may need to be made again and again, because the school has a 3D printer, the model can be redesigned for better suitage of her needs at a low cost.